Hi everyone. Our lesson for today is linear differential equations. A differential equation of the form dy over dx plus capital P times y equals capital Q, where P and Q are functions of x only or any constant, is called a linear differential equation, commonly known as Leibniz linear equation. Let us study how to solve linear differential equations of this form. We have two general steps. Step 1 is to find the integrating factor. We put capital I and capital F for short. The formula is here. It is equal to e raised to the integral of p dx. Step 2, let us find the general solution using the formula here. Y times if, that is the integrating factor, equals the integral of the product capital Q times if, then dx. Then we write plus c. Example 1. Find the general solution of the differential equation dy over dx plus 5y equals e raised to 2x. We can see here that our equation is on the form of the standard form already. So we can collect the p and the q. So the value of p is this number 5. That is the coefficient of y, and the q is this value e raised to 2x. And then let us solve for integrating factor, the if, using this formula, e raised to the integral of p dx. Our value of p is 5, so we will have this e raised to the integral of 5 dx. When we simplify this integral of 5 dx, we have this e raised to 5x. This is our if. Let us find the general solution using this formula. Take note, if equals e raised to 5x and the q equals e raised to 2x. So it becomes like this. For the left side, we will just combine this y and the if value. On the right side, on this integral, we will check for some simplifications. Like you see here, e raised to 2x can be combined with the e raised to 5x. So it becomes e raised to 7x. Then we will take the integral. The answer will be e raised to 7x all over 7 plus the c. This is now the final answer. Example 2. Find the general solution of the differential equation x times dy over dx plus 2y equals 3. First thing to do is to rewrite the equation into the general form. Because of this x, it is not in the general form. So what we'll do, we're going to divide this equation by x. So the new equation becomes like this. Dy over dx plus 2 over x times y equals 3 over x. And from here, we can collect the values of p and q respectively. The p is the coefficient of y, that is the 2 over x. And the q is this value 3 over x. Step 1, we solve for if using this formula, the e raised to the integral of p dx. Our value of p is 2 over x, so we substitute it here. Then we simplify the integral of 2 over x dx. And that will be 2 ln of x. We can simplify this 2 ln x into ln of x squared. Now take note of this e with the ln here. We can simplify this further into x squared. It means our if is equal to x squared. Then we go to the next step. Let us solve for general solution using this formula. Again, we take note that our if is the x squared and the q is the 3 over x. For substitution, it becomes like this. On the left side, we'll just combine the y and the x squared. Whereas, in the integral here, we can see some simplifications. We can cancel this x squared with the x in the denominator. So the integrand here becomes 3x. So it means we will simplify the integral of 3x dx. And it becomes 3x squared over 2. On this equation, if we want to make our y alone, we can divide this equation by x squared. So the resulting equation now is y equals 3 over 2 plus the c all over x squared. This is now the final answer. Example 3. Find the general solution of the differential equation x squared times dy over dx plus 5xy plus 3x raised to 5 equals 0. In here, we can see that it is not in the general form. So, we're going to rewrite this into its standard form. In this case, we will divide this equation by x squared and rearrange the equation. The resulting equation now becomes dy over dx plus 5 over x times y equals the negative 3x cubed. So once it is in standard form, we can now collect the p and the q values respectively. The p is the coefficient of y, that is the 5 over x, and the q is the value negative 3x cubed. Then we go for step 1 to solve for if. Our formula, e raised to the integral of p dx. Our p is 5 over x, so we have e raised to the integral of 5 over x dx. Simplifying the integral, we will have this e raised to 5 ln of x. Then we use the principle of logarithm. We can rewrite our exponent into ln of x raised to 5. And this e with the ln will cancel each other, and we simplify this further into x raised to 5. This is now our if. Second step, we solve for general solution. We use the if, that is the x raised to 5, and the q, and that is the negative 3x cubed. Doing our substitution, it becomes like this. We can see that we can simplify further the integrand in here. We can combine the x cubed and the x raised to 5. So we have this x raised to 8. We don't do anything on the left side, we just put them together. So the integral of this negative 3x raised to 8 dx will be negative 3 times x raised to 9 over 9, then plus c. We can cancel this 3 with this denominator 9, so we have this negative x raised to 9 over 3. Now, if we want to make this y alone in one side, we can divide this equation by x raised to 5. So the new equation will be y equals the negative of x raised to 4 all over 3 plus the c all over x raised to 5. This is now the final answer. I hope you learned something from this video. See you again next time.